And x1?
1.
All right. So could you subtract here for us, please?
Mm. 4/1.
Try again for the bottom. 5 minus 1.
Oh, 4, sorry.
4. Okay, good. What is 4 divided by 4?
8 with 2. Wait. 1, sorry.
It's 1. Yeah, good. This is one reason I like students doing math over fall break is you don't forget everything. It's easy to get back in school and you're like, I don't remember any of that stuff. This is good. Okay, so a couple of rules on the we should look at here before we do any more ordered pairs here. What if it's something like this? What if it's a -3 plus 2 over 5 minus 6? Could you tell me what the top and the bottom become in that situation?
The top number is -1 and the bottom number is -1.
And two negatives, what happens when you have the same, when they're both negative? Does the result become
Positive.
positive? Yeah, +1. Okay. Next thing is, let's say you get something like this, like -5 minus a -7 over 6 plus -2. What does the top become? What does the bottom become?
Would it be 2/4?
The top is 2, the bottom is 4. Does that reduce?
Becomes 1/4.
You can divide the top and bottom by 2.
Oh,
What does that become?
1, 2, 1/2.
1/2. Good. Okay. So you definitely have this down. So I'm okay for us to move forward to doing some of these slope problems, because you have to be comfortable substituting in. Now there's always going to be the subtraction sign. It's always going to be there. All right. We're gonna do a few examples together, and then I'll have you try some on your own here. But let's start with the easy ones. So here's a set of numbers, 3, 9, and 1, 8, like that. So it's x1, y1, x2, y2. Okay. So tell me what goes in the top.
8,
Okay. What else?
and then 9,
Minus 9. Okay. How about on the bottom?
and then 1 minus 3.
Okay. So I want you to simplify this completely and give me your final answer, please.
Okay. Positive 1/2.
So it ends up being 1/2. Very good. Okay. So let's look. We're going to increase the difficulty here a little bit. If you don't have this formula written down, you definitely want to write it down. I'm going to give you some problems to do on your own, but let's look at a few here together. I think it's really important to always identify, what is x1, what is x2, x1, y1, x2, y2. All right, so this one is 6 minus 2 on the top, and then on the bottom it's 5 minus a -4. The subtraction is always there. There's always going to be subtraction, but sometimes there's the -4 in this case, it goes to the right there. Okay, that's why we looked at a couple of examples where there was a double negative. Could you try simplifying this for us, please?
Would it be 4/9?
Yeah. Okay. So I'm gonna put the formula up here on there, and then I'm gonna have you try this one. What I'd like you to do is tell me the numbers that go in the top and the bottom. Tell me what goes in the top, tell me what goes in the bottom.
Um, so the 3 minus -5,
Okay, good,
and then 7 minus 5.
good. All right. Go ahead and simplify this for us, please.
We 4.
8/2, which equals 4. Good. All right, let's look at one more together, and then I'll have you do a couple on your own. All right, so there's this. Grab the formula again. As you're learning, it's really good to have that formula down each time. All right. What is y2 in this problem?
Net have 10.
What is y2? Try that one more time. I heard 10. Is it 10?
-10.
Yes, yes, very different. -10 minus what is y1?
1.
All right, and then x2.
3 minus 2.
Good. All right, could you simplify this for us, please?
Be uh -11.
Okay, over 1, which is -11. Good. All right. So here you go. Here's a problem for you to try on your own. Go ahead and work that out as best you can and let me know what you come up with.
Would it be +7/4?
Like this?
Mhm.
Okay, let's try it out. 1 minus 8 over 5 minus 9 is -7 over -4, which is 7 over 4. Really good. Okay, that was kind of the easy one, we'll say. I mean, when I say easy, I mean there's just degrees of difficulty on this. So let's do a couple more here. Um, this one's got a lot more signs involved, so be very careful here. Take your time.
Would it be +1?
+1 is your answer, like 1 over 1.
Mm-hmm.
So let's see, -4 minus a -5 over -7 minus a -8, 1 over 1, which is 1. Good. All right, good job. Let me put one more up in front of you, and then we'll move on to something different. we'll move on to some like terms stuff like we've been doing. But same thing here. If you could come up with the slope, please, I would appreciate that.
It would be 1/2.
1/2. Let's take a look here. So the slope is 0 minus 4 over minus 5 minus 3 minus 4 over minus 8, which is 1/2. Good. Did really good. Okay. So the next topic that we put on the list there is this idea of like terms. So something like this, like what is 6a plus 2a? What does this become?
The answer,
Yes. What does this become?
8A.
8a. And if it's like minus 5a plus minus 3a, what does this become?
-8.
Negative 8a, right? And so then you can get into more complicated problems where you could have different types of terms, like you could have 5x plus 3y minus 7x. So the like terms here are 5x and minus 7x. What does that become?
-2.
Negative 2x. And then is there anything to combine with the 3y? Can those be combined?
No.
No. Okay, that's good here. So let me find some problems here for us to work on that are similar to this. And let's work through a few of them. Boy, these look similar to ones you had in your class. Interesting. So I know sometimes teachers go out to the wonderful internet and try to do these. So here's a problem I found. Forget about that 28 for a moment. Could you try this on your own and let me know what you come up with?
Mhm. Would it be 5A minus 3B plus 5C?
Good, really good. Yeah, let me throw a couple more, put a couple more up in front of you, and then we'll talk about the more complicated ones. Here's another one for you to try.
Would it be -10D plus 5S minus 3?
Yes, perfect. Really good. Really, really good there. All right, good job on that. So I think you're pretty solid on that. Now, question for you is our x and x squared, are these like terms?
Um,
And if you're not sure, probably better just say you're not sure than to guess at this point.
yeah, I'm not sure.
Okay, so let me write them differently. Is x and x times x, are these the same? Are these exactly the same?
No.
No, like this one's got more x's. So the answer is that these are no, they're not like terms. No, they're not the same. So if I give you a problem like this, so I say 5x plus 3x squared minus 2x, the like terms are the 5x and the minus 2x.
Mm-hmm.
Okay, so this would become 3x plus 3x squared.
Mm-hmm.
All right. And so you could do the same thing like is y squared and y cubed, are these like terms?
No.
They're not. So if it's 5y minus y squared or 1y squared plus 2y cubed minus 6y minus 3y cubed plus y squared, which of these can you combine? Which are the like terms? Well, it's the y with the y. So it's the 5y with the minus 6y. It's the minus 1y squared with the plus 1y squared. And it's the plus 2y cubed and the minus 3y cubed.
Mm-hmm.
All right, so could you try to combine those for us, please?
Uh-huh. Would it be -1 minus
Negative 1y. Yeah.
oh yeah, sorry. -1 y
Mhm.
minus 1 and y and then the exponent of 2 and then -1.
So this one, I was just throwing this in front of you is being a little bit from it's minus. Let me do it in. Let me color code it here because I think maybe that's what's missing here. I know there's a lot. That's why it's hard to see here. So the blue is the minus 1y squared plus the 1y squareds. Those cancel. That's like saying like uh, these just cancel. They go away. This goes to 0.
Mhm.
And that's okay. That's 0. And then the last one here is plus 2y cubed minus 3y cubed. What does that become?
-1.
Negative 1y
Okay.
cubed. Yeah, y to the power of 3. The first one becomes minus 1y, like that.
Mhm.
All right, so minus 1y minus 1y cubed is your final answer. All right, let's switch topics here. We're going to switch to increasing and decreasing. So I'm going to put a graph in front of you. You were doing this in your practice last time. Um, and you're looking for the x value. So when I ask where it's increasing, I'm asking where it's going up and to the right, but it's the x values that I care about. What are the x values where it's increasing?
2.
The x values. What's the smallest x value where it's increasing? What's the x value there?
-4.
-4. Okay. And then what's the next x value?
Negative, +1.
Now it's decreasing if it's going down and to the right. And again, it's the x value. So what is the leftmost x value where it's decreasing?
3.
Leftmost, the leftmost one.
Oh, 5.
Okay, so we're talking about the x value though. The x values are along the x-axis here. Is that something new that you haven't seen much before?
Yeah.
Okay, so the x values where it's decreasing is 1 to 3. It's this first one in red and then the second one in red. Like anywhere along here, it's decreasing because it's going down into the right.
Mhm.
Up over here on the left, it's going up into the right.
Mhm.
All right, let's look at another graph here. Um, I actually thought that would go better. So let me grab a blank graph. I think this will work. Okay, so I'm gonna put something on here. Let's go. Okay, I want you to tell me where this graph is increasing, where it's going up and to the right. And it's the x values that we're looking for. What are the x values where it's going up and to the right? So like where my cursor is, what is the x value?
1.
Okay. What is the x value here?
5.
So this is from 1 to 5. Decreasing is when it's going down and to the right. So what is the x value over here where my cursor is?
-7.
Okay. And it's decreasing, 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 decreasing all the way to what is the x value there?
-4.
X value.
Oh, 1.
1. So notice I'm never asking you for anything except along the x-axis. Okay. So let me put a new graph up for you. Have you try this one. All right. So where is it increasing? Where is it decreasing?
It's increasing at -7 and then 2,
Okay.
and it's decreasing at 2 and 7.
All right. Do you remember what we call this on the graph when it's just going horizontally?
Um, isn't it constant?
Yes. So where is this graph constant?
Like, where is it in the middle?
It's the same as the increasing or decreasing. It's the x values.
Uh, um, -3 and 4.
All right. Now let's add to this a little bit. Let's do this. All right. Tell me where it's decreasing.
and 9.
Okay, 4 to 9. Is there anywhere else it's decreasing?
-5 and -3.
This is -6. Yeah, -6
Oh,
to
sorry.
-3. All right, good. Is it increasing anywhere?
No.
None. Okay, let me put a new problem up in front of you. It's more like what you were doing for us the other day. All right, I want you to tell me where it is. Constant, increasing, decreasing.
Okay. The constant is -3 and 2.
Nope. Where does it stop being constant? It's not at 2. Two is over here. So -3, what's the x value at that second red dot?
2 or
The x value.
0.
Yeah, 0.
Um,
Okay, and then there's another interval. What's the next interval where it's constant?
um, 2 and 3.
Okay, very good. Increasing. Increasing means it's going up and to the right. So where is it increasing? There are two intervals where it's increasing.
-5 and -3.
Okay, -5 comma -3. What's the next one?
3 and 4.
Good. All right, and where is it decreasing?
Um, 2 and 2.
Can't be the same number.
Oh,
And it's
oh,
it's
2,
it's it's the
2.
X values. Stop looking at all the Y values here. Just ignore those. Those aren't helping you,
So just
right?
0 and 2.
0 to 2. That's the first one. What's the other one?
4 to 5.
Yes, very good. Very, very good. Okay. Let me give you one more of those to try, and then we'll figure out something else to work on. Okay. Give me I know this is a little hard to see, but I think you can do okay. Give me increasing, decreasing, and constant. Or if you want to do constant first, it doesn't matter. The order doesn't matter to me. Just let me know what you want us to do.
Yeah. Okay, the constants, the increasing is 1 to 3,
Okay,
6 to 8,
good.
and then the decreasing is -5 to -2, and then 8 to 9.
Good.
And then the constants are -8 to -5, and then -2 to -1.
Nope, not -1. Try one more time.
Oh, +1.
Okay,
And then 3 to 6.
really good. Really, really good. Okay. All right. Well, that's a good review of everything that we've done. Let's look at something new. I'm gonna just ask you if you know how to solve one-step equations. Um, you can tell me if you've never seen this before, but I figured I'd throw it at you. Um, do you know how to solve something like this?
Um, we I think so.
Okay, because remember, if you tell me you think you'd know how to do it, I'm probably gonna ask you to do it. So do you know how to do you know how to undo subtraction? Because that's what you have here. You have a variable -4, you're subtracting 4. Do you know how to undo subtraction?
Mm,
It's okay if you don't. I'm just asking so that I know how much to say or not say.
No, I don't.
Okay, so you undo subtraction with addition.
Uh-huh.
Okay, so you're going to add 4 to both sides of the equation. On the left, it becomes 0. What is 0 plus anything? Do you remember?
1. It's the number you're
Yeah, it just stays the same. What about on the right? What's 3 plus 4?
7.
Yes. So you undo subtraction with addition. So let's look at another one here. Let's say it's x plus -3 equals 9. How do you undo plus -3?
Uh, you add it with the 9.
You add 3 to both sides. So x becomes what?
6.
You're adding 9 plus 3.
Oh, 12. Oh, I
12. Good. Now where these get a little more difficult is I can do the following. I can change the side. So I can say 5 equals x minus 2. What is keeping x from being by itself?
um
What do you see over here on the side with the variable?
2.
Subtraction by 2. So how
Mm-hmm.
do you undo subtraction?
Added addition.
You're going to add 2 to both sides of the equation. So you look at the side with the variable and you undo that. What is 5 plus 2?
7.
7. So from here, because this is awkward, you flip it, it's x equals 7.
Mm-hmm. Yeah.
Any questions on that? Thoughts on that?
No.
Okay. All right. So let's have you try solving a couple here. X minus 3 equals -1. Could you solve that for me, please?
Mm-hmm. Do you keep the signs when you add?
Well, this is something we were doing earlier. It was like, it's like, what is -1 plus 3 is what this is asking you to do. So this you've already done this. It's ones you've got one negative, one positive. They're opposite in sign. It's just like we were doing earlier.
So x would equal 2.
Yeah, good. Let's try another one here. Let's go -7 equals x minus 3. Could you try solving that for us, please?
Mm-hmm. would be -4.
Yeah. So x equals -4. Good. Okay. So the next type of problem we're going to look at is like something like this. X plus 5 equals -2. So you undo addition with subtraction. So there's a plus 5 on the left. We're going to undo it with subtraction. We're going to subtract 5 from both sides of the equation. This time it's -2 minus 5. So that's why that whole like combining same sign, opposite sign, it's so important. You have to be able to solve something like this. So what does this become?
-7.
Yeah, x equals -7. And then you can always have, you can always have the wrong side. You can say like x plus 2. What do you do to solve this?
You subtract 1, -1 minus 2.
You look on the side with the variable. Look at the side with the variable. What's keeping the variable from being by itself?
The x.
No, plus 2.
The 2. Yeah.
How do you undo addition by 2?
Subtraction. Oh, yeah.
Okay.
Subtraction.
What is -1 minus 2?
-3.
So x equals -3. All right. So you can always, some other things you'll see here is you can change variables. Like I can put in p minus 6 equals -7. And then over here, I'll do like p plus 3 equals -5. So will you try solving each of these for me, please?
Mm-hmm. Okay, first one would be p equals -1,
Good,
and then the other one would be t equals -8.
good. Yeah, very good. Okay, so you got that down. So some other kind of variations on this, you might see something like this where it's like -4 plus m. Okay. When you look at the side with the variable, this -4 is being added, but because it's subtracted, because it's a negative, you undo that with +4. So you might see something like that, where it's -4 equals m. You might see some problems like that. All right.
Mm.
Okay. So let's take a look at something like this. 3x equals 12. How do you undo multiplication?
Um, division.
Division, yeah. So you look at the side with the variable. The side with the variable, you don't care about the other side. Side with the variable, and you divide by the number in front of the variable.
It'd be 4.
Yes. Now let's say it's -5x equals 20. What is the number in front of the variable?
-5.
So you divide both sides by -5. What does x equal?
Um, be -25.
You're dividing. You're dividing. So how many times does 5 go into 20?
10.
Nope. So 5, 10, 15, 20. These are the multiples of 5. That's 5 times 1, 5 times 2, 5 times 3, 5 times 4.
Oh, sorry. I got before,
Be -4, yeah. Why is it negative?
because there's a -5 and you're
Yeah.
keep the sign.
So you could also switch sides. Like it could be 18 equals -6 x. You look at the side with the variable. The -6 is multiplying x. You undo that with division. What is 18 divided by -6? What does that become?
-3.
Yeah, so x equals -3. Cool. All right. How do you undo division? Let's say it's y divided by 2 equals 7. How do you undo division?
Multiplication.
Multiplication. So you multiply both sides by the number that's on the bottom. So y equals what? What is 7 times 2?
14.
14. All right. So here we go. Let's give you a couple of problems to try here to close out. Let's say it's a -4x equals -16, and y divided by -3 equals 2. So let's have you try these and see what you come up with, please.
The first one would be 4.
Yep,
Or
you're dividing both sides by -4, so that's x equals 4. You want to say the whole thing though. X equals,
okay. And then y equals -6.
yes, you're multiplying both sides by -3. So y equals -6. Very good. All right. Hey, good job today. Great effort. Hard to do when you're on a break like